Welcome. I'm going to show you how to do a power analysis in ASA, and I'm also going to illustrate the concept of effect size sensitivity. So the first thing you'll want to do is to start up ASA Navigator, which I've already done here. So I'm going to scroll down to the folder that focuses on sample size and power analysis. That's right here. I'm going to expand that. I'm going to show you how to do a power analysis for a correlation coefficient. We'll keep it simple. So I'm going to expand the power analysis for correlations, and I'm going to click on the program for power for a correlation. And if I double click on this, it'll start up the program. So I'm going to go ahead and do that. Okay, I'm going to center the program for us. So the first thing I need to do for the program is to specify a minimal population that I want to be, a correlation that I want to be sure to detect. So I'm going to enter a correlation of 0.20. And what that means is if the population correlation is 0.2 or greater, I want to be sure to detect it to get a significant result. But if the correlation is less than 0.2, I don't care if I miss it. Now, in my study, let's suppose that I think I can reasonably get a sample size of 125. So I'm going to put a sample size of 125 in as my target sample size. The program is going to generate a power table for us, or what I call a dynamic table. And that table is going to have different minimal population correlations as columns. And these are the default values here that we're going to use. And it has sample sizes, different sample sizes as rows. And these are the default values here. And the entries of the table are going to be the power values associated with a given column and a given row. So one of the things you want to make sure is that the sample size that you have up here is in the sample size rows down here. So if I actually was interested in a sample size of 120, then I might alter this table by adding 120 so that I have that as a row in the table as well. But I'm going to zero in on a sample size of 125, so we don't need to do that. So I'm going to hit calculate. And here are the results. So for a minimal population correlation of 0.2, a sample size of 125, two-tailed alpha level of 0.05, my estimated power is 0.62. Is the probability I'd be able to detect that correlation of 0.2 or greater is only 0.62, and that's too low. We generally want power values of 0.80 or greater. Now if I go down to the table and I look at the column that has the population correlation of 0.2 in it, I can scan down until I see a power value of 0.8. And you can see that that occurs right around a sample size of 200. So what that means is that if I want to have sufficient power to detect a correlation of 0.2 or greater, then I'm going to need a sample size of about 200. Now let's suppose I can't get a sample size of 200. That because of practical reasons, the largest sample size I can get is 125. So then the question becomes, if I'm stuck with a sample size of 125, what correlation will it be sensitive to in picking up? So if I look across the rows, I'm going to go across until I find a 0.80 entry using the power of 0.8 as my sufficient power. And you can see that that occurs somewhere between a correlation of 0.2 and 0.3. But this values of 0.62 and 0.937, there's a fairly large disparity between them. And I want to do a more fine-grained analysis to see where that value of 0.8 occurs. So I'm going to close this, and I'm going to come back to the original table. And instead of using the default values, I'm going to change them so that I'm using a values between 0.2 and 0.3 that are a little more fine-grained. So I'm going to change this to 0.21, this to 0.22, this to 0.23. This to 0.24, this to 0.25, and I'll throw in a 0.26 for good measure. For the sample sizes, I'm really only interested in a sample size of 125, So I'll reduce this to a smaller number. And it turns out in this program you have to have at least 2 entries for rows. So I'm going to go ahead and put my target sample size of 125 and then the sample size of 200 from our original analysis. Hit calculate. Here's the new table. So if I look at my sample size 125 and I look to the right until I get a value of 0.8, you can see that that happens right around a correlation of 0.25. So what that means is that a sample size of 125 will have sufficient power to detect a population correlation of 0.25 or greater. And that's the effect size sensitivity of a sample size of 125. The effect size sensitivity of a sample size of 200 is a correlation of about 0.20 or greater. So a sample size of 200 will have reasonable probabilities of detecting a population correlation of 0.20 or greater. When we summarize power analyses, it's often very useful to do so using the effect size sensitivity. So if I'm writing a grant proposal, for example, and I'm justifying my sample size of 125, I might say that that sample size with a two-tailed alpha level of 0.05 and a criterion of power of at least 0.8, that it is will have adequate sensitivity to detect correlation of 0.25 or greater in the population. Okay, thank you.